The issue here is we're looking at the foundation systems under pole mast arm systems that we were concerned about is when we have a hurricane, we have to be able to sustain the expected wind loads and not have distress or failure related to our poles coming down, as well as our mast arms rotating and possibly translating and hitting a structure like a passing 18-wheel truck or a car or whatever. So we're going to test one of those. If we go down and go down the line here, we have shafts that'll be 18 feet long, and these 18-foot long shafts will hopefully only rotate when we apply the lateral load on them, and that will be safer for the public in terms of the expected wind loads from a hurricane in terms of that behavior. Here we're looking at specifically the foundation and the connection between the foundation and the pole and the mast arm system itself. And that's where, in the past, when we looked at past hurricanes, we've seen that we had failures in terms of the connections. And so we had to test one of the newer type connections here to prevent that type of failure. So if you look at that, we had that embedded pipe in that system, and that was very nicely, it transferred that load very nicely. We had no failures related to that. And we did fail, like we wanted to fail, the foundation. We did fail the soil shaft interface to see what the capacity of this object is. So when I design this, I have to design this for a particular nominal resistance or a peak load, and then I put a resistance factor, we call this a phi factor on this, and that will reduce the load. Typically phi factors we use are about 0.5 to 0.6, somewhere in there, and that tells us what allowable load we can apply on this type of foundation system.